for animals. Yeah, see, Big Meow has actually 34 hamsters. That's just two of them. I have a rabbit. Donna has a dog. But he looks after a cat that stays near his hostel. And Jeremy has a 7-year-old terrapin. Yeah, so all of us actually really love animals. Then we wanted to actually build a robot that can actually help animals. Okay, that's one of our first motivation. Our second motivation is that all along, all the projects you've seen, basically, you're always seeing how robots actually interact with humans. But then we wanted to be like slightly different. We want to explore the obscure possibility of actually animal-robot interaction. Yeah, that's our second motivation. Okay, then initially we wanted to build a robot that can actually be suitable for all pets. But then just for this project, we decided to scale down and have it just for dogs, because dogs are after all man's best friend. Okay, so that's how Dog Popular was born. This is the overview of the whole lecture. First off, not lecture, the presentation. First off, I like to start off with the user study. From the user study, then we actually know what the users actually want the robot to do. Okay, after we know what they want to do, we actually move on to the design process where we'll design our robot based on the user's input. And after that, we go on to the implementation where we actually implement our design. And lastly, we actually conduct a user evaluation to see how successful our implementation was. So I'll move on to the user study. We actually use two methods, the online survey and interview. And for the online survey, this was one of the questions that we posted. So we actually asked them, imagine you're going to build a robot for your dog. What 3 things would you like this robot to do for you? So the top 3 responses were actually basically, some people wanted the robot to actually play with the dog. That's our most popular response. The secondly was to actually to let the robot display the dog. Because there may be instances where the user is in the office, in the work, then he misses the dog. So they actually wanted the robot to be able to show the dog to him. And the third most popular one was actually the users wanted the robot to actually feed the dog for them. Other less popular responses would be to clean up after the dog or to keep him occupied. So that's the responses that we got from the online survey. And then for the interview, these are some of the results.
So imagine we're going to build a robot for you. So what 3 things do you want this robot to do?
I would like the robot to video him.
Let me see her. Just keep him company.
Entertain him.
Yeah, so we went door to door to knock on the doors of people, and we actually asked them permission to interview them. Yeah, so these were some of the responses that they gave us. That's our user study. Based on this input, we actually move on to our design. So basically that's our design. We basically, based on the user's input, we had the design a ball launcher to actually allow the user to remotely play catch with the dog, the webcam to provide the view of the dog, and a feeder to feed the dog remotely. However, this design has several problems. Okay, the first problem is, how do we trigger these components? We cannot just take all these components and put it on the robot and expect them to work. We have to have some kind of method, some kind of way to actually trigger these components. Okay, then our second problem was, how do we automatically reload the ball? Okay, with the ball launcher, and if the user is in the office and he presses, okay, fire the ball. But how are we going to get the ball to be reloaded back into the gun? That's our second problem. And our third problem is actually that the components are not easy to activate. For example, the ball launcher or the dog feeder, these components are actually built for humans to activate. So they have buttons and such. So it's not easy for a robot to trigger them. So this is how we actually solve the 3 problems. Okay, the first is, how do we trigger these 3 components? We actually use the USB cannon. USB cannon is this device that is a USB cannon. It connects to the computer, and there's an interface on the computer where the user can like press left, right, up, down to control the cannon. Yeah. It's the user controlling it. Yeah, so the user actually has control over it from the computer. Okay, then that's our second solution. How do we automatically reload the ball? So we simply replace the ball launcher with a bubble blower. Yeah, we basically got this idea when we were at the park doing natural observation. Then we noticed some people actually playing bubbles with their dogs. So that gave us the idea of instead of using balls, why not use bubbles? So we went back to YouTube, and indeed the response was actually quite good. All the dogs actually were quite interested in the bubbles. So that led us to the last problem. How do we solve the problem of the components being hard to activate? As you can see, we bought this bubble blower from Toys R Us. Then it has a button, which is for children to press. But it's not easy to activate it using the USB cannon. So I actually modified this bubble blower. I extended out 2 wires from the circuit. Then I put aluminum foil to increase the surface area. Then I put a conducting material onto the cannon, USB cannon. So when the USB cannon is programmed to lower itself, it will close the circuit. So the bubble blower will actually work this way. Yeah, so I will now proceed on for the demo to show you how it works. Sorry, you're going to connect to the interface.
That's it all.
First and foremost, what the user sees on his client laptop is this screen. So the first basic function he has is to be able to move the robot around his house and try to locate the pet, as you can see. So he found his pet. So he can proceed to his pet. Okay. So now we know that it's a pet. We can proceed to feed the pet by clicking the drop flex button. So you see that they actually got snacks for the time to eat. Okay, yeah, okay. So now the pet is bored. This machine can also dispense the bubble. So the user can just go and click bubble on. Yay! Wow. Right. Okay, he's loving it. Okay. I know that this is actually connected from a client laptop to a server which is placed on the robot itself. And it's not this laptop connected to the robot directly, it's connected to the net. So the client, the user can actually connect from overseas or from at work, for example, to be able to see what's going on at home. Yeah, that's the end of the
I'll start to do my presentation. Alright, Adrian has briefly discussed just now. Firstly, we have the Roomba, and on top of it, there's Adrian's laptop. This acts as our server. Connected to the server are 2 items, the USB cannon and the webcam. Okay, the USB cannon, in turn, triggers the bubble blower and the dog feeder. And all of these components are actually triggered by the client computer. The client computer is actually a computer that the dog owner uses. So the dog owner sends a command over to the server, and this controls everything. That's our system architecture. It's basically what you just saw just now. It's the dog feeder. is the webcam, the USB cannon, the bubble blower. And this was the interface that you saw working just now. Okay. Now we also conducted an evaluation. We actually interviewed 3 participants and their pet dogs. 2 of the participants actually came from our data gathering stage, the interview stage. So we actually went back to them and asked them to check out our robot. So we have Fiona, she's a mid-40s, she's a teacher. Our second participant is Cheryl, she's 22 years old and undergraduate. And our last participant is Samantha, she's a primary school student. Yeah, the main aim of the user evaluation was actually to find out 3 things. How well the dog can actually interact with the robot, whether the dog will be scared of the robot or any other stuff, and the interaction between the interface and the owner, whether the interface is intuitive enough for the user to actually use. And the last one is the indirect interaction between the owner and the dog, whether the owner can successfully play with his dog through our robot. Okay, here's a quick video. Actually, this was actually done. We had the user sit in a separate room. Then the dog was in a separate room, so she actually had no sight of a dog. So she actually used the interface and actually interacted with the dog. So the results, for the interface-wise, actually all 3 of the users found the interface intuitive. They were able to utilize it without much any problem. For the feeding-wise, they all thought it was a good idea. They liked the idea of being able to feed the dog while in the office. For the surveillance-wise, 2 of the participants didn't have any